So, hello everyone. It's really a pleasure to be here with you and see all these people in the stage. And in this talk, we'll see how to build a web maps using Django. But I'll try to do that telling a story of one of my past hike in the mountains where I took this picture you can see here. But if you're asking yourself what type of maps we can build with Django, let's see an example. This map shows mountains, peaks all around the world. We all use map like that every day's web or mobile app. And I built this map with Django. And in this talk, we'll build together a map similar to this one. But first, I present a bit myself. So I'm Paolo Melchiorre. This is the link of my blog. Someone already know me here in the DjangoCon US. And in fact, Bartek took this picture of me in San Diego during DjangoCon US 2022. I like the Django and Python community, and I try to be more involved in the last 6 years. And other than working in the global community, I tried also to help the local Italian and community. And I founded a community in Pescara, my hometown. And I really like hiking in the mountains around Pescara in the Abruzzo region where I live. So I decided to build a map where I can add all the mountain peaks I've reached in past hikings. But in this talk, I want to share one particular hike I did some years ago. I took this picture from the starting point of this hike. It was very early in the morning. I was in the Italian Apennines in the center of Italy, and the sun has not yet risen. We can see the lights of the cities along the coast, and in the distance there is the Adriatic Sea, but it's covered with the dark. The making of this map, this talk, will be a bit like this hike. We start from an easy stretch, and then we go up in altitude. So let's start from the basics. A web map can have a lot of features, different features, can be dynamic, static, you can interact with the map or only view it. The map can use raster vector tiles to represent the surface. Usually the data is stored in a spatial database, and a web map will use JavaScript library to show dynamically the map in your web page. The definition of Wikipedia say that web mapping is the process of using the maps delivered by a geographic information system. But implementing a GIS from scratch is beyond the scope of this talk. Instead, as a GIS, we are going to use Django, our preferred web framework, and in particular the GeoDjango module. A warning, in the next slide, I show you some code formatted to fit the slide space. Sometimes it looks peculiar, but you can copy and paste and run it, and it works perfectly. So we can start from the requirements of our project. To create a Django project, we need a stable and supported Python version, a virtual environment, where we can install the latest version of Django. As usually, to start creating the project, I switch to my project directory and I use the start project Django command and the basic files our project will be created for us. After entering the new my map directory, we create a markers app and with the startup command, and again, all the file will be created for us. Now we have to activate our marker application, inserting its name in the list of the installed apps in the setting file. We create a template file in a template directory, and we add only the usual boilerplate, a title in the heads, but an empty body content that we'll fill in a bit. To show our template, we create a new URL file in the marker app. We add our path and a template view which use our template file. And as the last step is to include the URL file in the one of the project. So if we will start now the project and visit the map path, we'll see only a blank page. As for the starting of my hike, there is nothing to see, so we can go up something more challenging now. I took this picture after walking half an hour in the dark. You can see the starting sunrise in the distance, and we are about to start the high altitude path here. As for our hike, we are starting to see something in our map as well. In fact, we hold an empty map using the Leaflet library. Leaflet is one of the most used JavaScript libraries for web maps. It's free software and it's desktop and mobile friendly, it's very light, and it has a very good online documentation. To add Leaflet in our map, we need to link in the head of our template its JavaScript and CSS module. And in addition here, using the Django static template tag, we will also link our custom CSS file. In the body of the template file, we add a div tag with a specific ID, and below it we link our custom JavaScript file. In the CSS file, we add only the basic rules that are useful to show a full screen map. Instead, in the JavaScript file, we add the code to show an empty leaflet map. Using the variable, we initialize our OpenStreetMap layer. We connect the newly defined layer to our map ID. And in the last statement, we set a map view to show the whole world. We can now run our Django project using the run server command. If you see logs like that in your terminal without errors, the map is ready. Okay, we just created an empty map with Django. The result is pretty much what you see now. It's an empty map without marker showing the whole world. So we start seeing something just like in my hike. This is a picture that shows a crossroad at the end of the first part of my hike, just before a very challenging uphill stretch. The sun has risen and the landscape is visible around. So after having visualized our map, we'll now start with more elaborate part, writing more code to create our markers and show them in the map. To do that, it's time to get to know and activate GeoDjango, the Django GIS module. Django added geographic functionality a few years ago with specific fields, database backend, special queries, and also the admin integration. But since then, many new useful features has been added every year until the latest version. And to activate it, we need to install before some requirements. The first one is GDAL, which has a mandatory requirement for GeoDjango. It is an OSGeo library for rendering and writing raster and vector geospatial data formats. It has a lot of command line for geographic data processing. To install it on a Debian-based system, you can use the apt package manager, or in Docker, if your Docker image is based on the Python bookworm image, we can install a smaller package which contains only the library itself without all the commands that are useful in the development stage. We can now activate GeoDjango by adding the contrib JS module to the installed apps in our project settings. But to use GeoDjango, we need also a compatible special database backend. In this first stage of this talk, we'll use SpecialLite, the special extension for SQLite. SQLite is the default database backend. It provides vector database functionality. And Specialized it has a very simple architecture, which is a complete database in an ordinary file, which is very convenient to experiment. As before, to install Specialized package on a Debian-based system, we can use apt package manager, and in Docker, based on the Python bookworm image, we can install it in this way. And after that, we add Specialized as a database backend in the default engine in our project settings. Now that we have set everything, we can define our marker model to store a location and a name of the point we want to add in the map. The two fields are both mandatory. The location is a point field that we can use in everything from GeoDjango, and we use the name to represent our model. We use the Django admin interface to insert new marker in the map. We define a marker admin class by inheriting the GIS model admin class, which uses the OpenStreetMap layers in its widget. Before creating a marker instance in the admin, we have to generate a new database migration with the make migration command. And then we can apply the migration to our database, in this case for the first time, using the migrate command. So to access the admin interface, after starting the project locally, we need to create a new user with the create super user command. And we can run again the Django project using run server and visit at the end our admin section in the browser. So this is the admin generated page for creating a new marker. We have a text field to enter the name of the point we want to reach and a map widget. In this case, we have to manually navigate the map to select a point in the space. In this example, I selected the point to the final destination of my hike, but I added also other points in the database to see something on the map. We can now show in our map all the markers I added through the admin interface. To do that, I created a map view with subclass the Django generic list view. We are going to use the existing map template, the marker model, and a custom context object name. We convert the markers retrieved by the list view to the GeoJSON format in the context data of our map using the serialize specific for GeoJSON. Now in the marker URL file, we must assign the map path to the newly created map view, and we can add the JSON data in a secure way in our map page using the JSON script template tag in this way. The value of the markers in the context dictionary will be something more like this GeoJSON created automatically from all the markers, but in this case, for space purpose, it contains only one marker, but with all the information, the properties and the geometry information. We need now to edit our JavaScript file and store the GeoJSON in a variable. Starting from this variable, we built a layer for our map, and we extract also the name of the single marker, and finally we add the layer in our map by setting the widget to contain all the markers, as you can see from the last instruction. In this way, when we open the map, we see all the points. Okay, we can run again our project and see the marker in our map. Okay, in this map we see the few markers I created through the admin. They are inside the HTML code of the page. Sorry. But the rendering is still fluid and fast. You can also see the pop-up in the marker of the peak of this hike. Don't know what is going on. Okay, but if we had more markers, and our map loading will be much slower, and also Leaflet will have a harder time to rendering it. In this case, we will need a more complex solution. This picture shows a beautiful landscape that came to my sight at the end of a very challenging climb, and the ice peaks begin to be seen. But in front of us, there is still challenging passages before to reaching the highest peak. So we then continue implementing the final version of our map. This is the compatibility table of all the open source geographic backends created from the Django documentation. As you can see, PostGIS is the only geographic backend that supports all the features of the GeoDjango feature. So let's use PostGIS as a backend engine. PostGIS is a Postgres extension, and it's the best database backend for GeoDjango. It internally integrates all we need to work with maps. To use PostGIS, we need Postgres and so PsychoPG. But the requirements of our project is increasing, so I created now a requirements file with a list of packages. In addition to Django and PsychoPG, we are going to use also Django filter, Django REST framework, and its geographic add-on. We install all the requirements from the file using the Python package installer module. And after that, we can modify the project database settings, adding PostGIS in the engine and all the connection parameters for our Postgres database, which you can have locally in Docker or remotely. We have to apply again all the migration to the newly created database because we already created it and it contains nothing. In this part of the map, we want to create a RESTful geographic endpoint to serve our markers. We need to use Django REST framework and its geographic add-on directly in our code, so we need to add them in the installed apps in the settings. First, we create a serializer for our marker class, inheriting from Geo feature model serializer. We only have to define an optional list of fields to be shown as additional properties, the geographic field, and the model itself. Now we define a read-only model view set for the marker. We set the bounding box filter to filter our markers and the type of filter. We are going to return all the marker instances in our database, and the serializer class uses the marker serializer that we already created. In the marker application, we define the URL of our new endpoint using the Django REST framework default router to create a new API path. And finally, we add the URL file to our project in the URL file of the general URL file. So move on to update our JavaScript file as a last point. As we no longer have the data preloaded in the page, we no longer have a way to position the map. So to show all the markers, we try to locate the user through the browser that will ask the user to share their position. And we'll use the shared position to center the map. Otherwise, we'll center it in an arbitrary point with a low zoom level. And we create also a layer group in the map that we'll use in a bit. We now load the marker fetching the GeoJSON representation from our endpoint, which will return only the markers of the specified displayed area that we can provide using the boundbox string. To render the markers, we load them asynchronously. We clear all the markers in the layer group when we're moving the map. Then we extract the properties we want to show in the pop-ups, in this case, the name. But we invoke this flow only when the user stops moving the map. And this way we retrieve a minimum number of markers, but only when we need to render them. And so the response is light and fast. So let's run again our project one last time with the run server command and finally see our markers in the map. This is our final map. This is only a screenshot, but it represents what we see in this specific area. Try to create an animated GIF with a low quality version, but I can assure that the loading is very fluid because the API calls occurs only when the movement on the map stops. So the data traffic is the essential, and the rendering leaflet is very fluid. Okay, our map project. As our map project, the hike has also reached the final destination, but unfortunately the view in the photo is a bit covered by clouds. But I can add a new marker now in my project with these peaks I reached. So I walked 27 kilometers and reached almost 2,800 meters above the sea level. It was one of the longest hike I ever made, and I hope to be able to do a new one soon, so I can tell you about it. What's next? There are also many other features that we can add in a hypothetical map. For example, marker customization pop-ups, marker filtering based on the relational data, the clustering of the points in front end and back end, the geocoding using for finding a point based on the address, and so on. Before saying goodbye, I want to share with you some tips based on my experience working with maps in Django, and is read the documentation in GeoDjango because it's full of information. Read also information from PostGIS website because it contains a lot of information to low-level queries. And try also to read the source code from GitHub because there is something that you can learn only from the source code. And last tip is search for question on the GIS Stack Exchange, but try to solve the question by yourself. You will learn more than reading the answer. Last things, you can also use this slide in presentation to learn more about web maps because it's released with Creative Commons, and you can find it using this QR code because it's the address on my website where I share in a few hours the slides and also other information on the talk. These also are my connection on social. You can reach me through that, or you can also stop me here at the conference to ask other questions about maps or other things, also hiking in the mountains if you like it. So thank you everyone.
What would be the next peak if you're building out a real-world website? Is there an obvious next level of difficulty or complexity when working with maps in Django? I know that's a broad question, but
yeah, I wrote 2 articles about this topic, and I'm writing the third one. I'm dealing with querying the OpenStreetMap database remotely to have more information based only from the points. And also I'm trying to find a fluid way to extract the information, from the local information from our picture, because now there is also metadata that contains all this information. You can extract the latitude, longitude, the altitude also. And I want to try to upload an image and all this information extracted automatically from it. So this is instead of navigating manually or writing manually the information. Thank you again.